Hello, everyone, and welcome to today's online meeting on the topic Encryption and Secure Video Conferencing, what you need to know now. Presented by ITU cybersecurity students of the class Advanced Cybersecurity, hosted by Dr. Mamoon Samaha. My name is Zoe, and I will be moderating today's event. But before we start, I would like to hand over to Dr. Mamoon Samaha, our professor of this class, to welcome all of you.
Thank you, Zoe. Welcome to the class, and thanks for making the time to be with us. I learned a lot from my managers and my educators in different countries, different universities. I want to mention my mentor, Phil McKinney, and Yao, and other people, including my PhD supervisors, John Kim and Dr. Jahan. So thank you so much, everybody. I learned that because I love education, my job was and will be always be to share and establish networks so we can work together. So if you are thankful for what you have learned in the class, in the cybersecurity classes, in the ITU and other places, please do share. So thank you for making this presentation, and thanks for the attendees. Thank you.
Thank you very much, Professor. So again, welcome everyone, and we are very excited to present or host this event today for you online. We have exciting topics to cover. We have 7 students today with us of the class Advanced Cybersecurity who will be presenting on the overall topic encryption and secure video conferencing, but we will dive into specific topics listed here on the agenda. We will start with an overview of encryption modes and also see a hands-on example in Python code on symmetric and asymmetric encryption. After this, we will dive into a real example and say, okay, what type of encryption are actually used on video conferencing tools such as Zoom or Gmeet, as well as WebEx and others. Authentication is also a very important topic in video conferencing tools and in security. So we'll be covering authentication flows with JWT. And in the end, it will be also exciting after all the other topics. We dive into a real security setup on an example called Jitsi video conferencing. And we will be introducing Jitsi Meet throughout this conversation here today as well. At the end, we would like to invite all of you to a networking and question and answer session. So please feel free to use the chat on the YouTube live stream. We have a host there. Anna will be collecting some questions. You can directly interact with us there. And please feel free to share information about yourself, where you're joining us from today, what is your background, as well as raising questions. Again, we will consolidate all questions and answer them in the end of the event. We have content covered for around 1.5 hours. And yeah, with no further ado, let's start with our first agenda point. And I would like to introduce Omkar Bain, who will be giving the overview of encryption modes, as well as Zilin Chu, who will be giving the hands-on example in Python on symmetric and asymmetric encryption.
Thank you very much, Zoe. So first of all, I'd like to thank my professor, my wonderful colleagues who made this event possible. I'm glad to be a part of this event. Today I'm in front of you. I'll be describing talking about encryption, the basics of it and what it is, the different types of encryption modes, which are there which we use daily in the real world. So basically, there are 2 types of encryption. First is symmetric encryption, in which we use only one key for the end-to-end communication. So, and the another one is asymmetric encryption, in which we use 2 keys. First is private, and the another is public key, which is used for encryption and decryption purpose. So this is basically a major difference between symmetric and asymmetric encryption. So to understand it better, over here we have two examples. So for in symmetric key encryption, the original text, right, our raw text data gets converted to ciphertext, and for that process name it as encryption, which we can do using our symmetric key. And then the same symmetric key can be used to decipher, to convert that encrypted data back to our original text. And that process is known as decryption. So we use same key to encrypt and decrypt. It's the same key which is used for end-to-end communication. The best example is like you're forming a VPN tunnel, or if you come from a technical background, you should be familiar with that. And yeah, this is a symmetric key encryption. And asymmetric key, we use two different type of keys. First is public key, and another one is private key. So our original text, whatever we have, we want to send it like through like encrypted through a secure channel to our end destination. That gets encrypted, and then as we see that the data scrambling is done. So that text is encrypted, which cannot be like it's not like human readable. That data gets scrambled, and then we use public key to encrypt it, and then it is sent over the cloud or over the tunnel to our end destination. And then the same data gets decrypted using the legitimate user who is present at the remote location. And for that, um, he or she uses the private key to decrypt that information. So this distinguishes basically the symmetric and asymmetric kind of encryptions. So let's move further. So we have, these are the encryption mode types. First is AES. So it's like a symmetric key encryption algorithm. So this is an example of symmetric encryption type. And it has fixed blocks of data, possibly of 128 bits at a time. Second is RSA, which we are like most familiar with. This is an example of asymmetric encryption. That means we use two keys, private and public. And the third one is this is the most important one actually, ECC. Um, in this, a method of public key cryptography is like based on use of elliptic curves over finite fields. And the most important difference which distinguishes ECC from RSA is the key size. So basically, what does we understand from that, or what does that mean? So ECC basically it provides the same cryptographic strength, right, to your data when you encrypt that data and then send it over. It provides the same cryptographic strength and as the RSA provides, but with much smaller keys. For example, a 256-bit ECC key is the same as like 3072-bit RSA key. So uh, the point over here is we can encrypt the same amount of data even with like much more stronger strength, but using a limited number of or a lower number of keys, like like a bit size. So that is the main difference between ECC and RSA, and ECC is always preferred over RSA. Okay, so these are again the main modes, actually ECB and CBC modes. Over here, right, electronic code book. So this is like a first generation of AES basically, and it is the basic form of block cipher encryption. So over here, right, from this image, as we understand, if we send our data unencrypted, right, if you're not able to encrypt it, we anyone can steal that information. So basically, this image, if we want to send it, if we are sending it unencrypted, if you are not applying any encryption algorithm, then this image will be visible, and any malicious hackers or attackers will be able to steal our information. And the ECB mode, it is the data gets encrypted, but it is like not up to our expectations. For example, ECB mode and CBC mode, if we compare, um, CBC mode, it's like an advanced form of block cipher encryption. And with CBC mode encryption, it's like each ciphertext block is dependent on all the plain text blocks until it gets processed further till the end. So this adds like an extra layer of security or complexity to the data which is encrypted. So that's why we will see in ECB mode, at least we will see like at least um, a bit of information, or if we can try to guess what that information is, we can try to predict it. But in CBC mode, that cannot be like happen. It cannot be achieved because of its complexity and the encryption strength. Okay, so why is data encryption necessary basically? So these are the three important points actually to maintain privacy. So that's true, right? Because all of our information needs to be private, or we cannot just give our confidential information um, to everyone. The security, yeah, the security is also a most important factor, like it's these days, because anyone can steal your information. As I described before, if you are not encrypting your data, it will it will get leaked, or the data breaches can happen. So in order to avoid that, we need security. And the another one is authentication. So there are various things, various type of authentication techniques are available. For example, if you're familiar with radius or TACACS, but I don't want to dig and dive into in depth in detail of those, but I just want to let you know, for authentication is also like data encryption is necessary. Basically, when we visit any bank website or any other website, right, they will ask you for the credentials. So that's how they will verify your identity, and the data, whatever you feed in, it gets encrypted. Even if you are checking out, or if you are buying anything online, the, a small like lock icon will appear. So that's how like the data gets encrypted. That's the basic difference between data encryption and the non-encryption basically. What is an encryption algorithm? So as I said before, like encryption algorithm is it's like a mathematical formula which is used to transform the data into ciphertext. So whatever data, when we send it over, right, it's like a human readable, like it's plain text. So if we want to send it encrypted, it will be converted to a ciphertext. So this is basically a term which we can denote it for any encrypted data, ciphertext. And an algorithm like this algorithm like will be used as a key in order to alter the data in whatever way we desire, like predictable. So that even like, even though the encrypted data will appear as like a text, or it can be like turned back into plain text by using the same key again. And these are some of the examples basically. um, AES and Blowfish are examples of symmetric encryption algorithm, and RSA and ECC goes with asymmetric encryption algorithm. Okay, so how is like encryption used to keep internet browsing secure? So have you ever wondered, right? If you type in any website, there will be a small lock icon will be appearing at the address bar. So what does that really mean? That if you hover your mouse over there, then you will see like that connection is secure. So this is just an example to illustrate uh, what it really means. So this actually verifies the identity of the website, the identity of the server, that this data is encrypted, and whatever we feed in, our data will be secured and it will not be leaked. So we need to be aware that whenever we do any transactions, or any or if you want to send our data, we need to be like proactive and ensure all of these things are taken into considerations. And the right, the right screenshot, like it shows like a certificate. Basically it's issued to google.com, and who has issued it, and the validity, right, it's valid from this date to this date. So all of these things makes this website secure and encrypted. Our data gets is encrypted. Like we are sure that if we send any communication, or if we log into our accounts, or send any data, right, it will be encrypted and it will be secure. Symmetric AES. Um, these are like we can use it like use AES ECB mode to encrypt decrypt text in Python, and more advanced approach. So the more practical stuff is interesting, and I would like to welcome my another colleague, Chu, who would be demonstrating a practical uh, example of this.
Thank you, Omkar.
Thank you.
So hello everyone, I'm Chu. I'm Zolin Chu. So I'm going to introduce how to code in Python, code the symmetric encryption and asymmetric encryption. So the first one will be the AES encryption. So we will do 3 following code. The first one is we will use the AES ECB mode to encrypt the text in Python, and the second one, the second one is the advanced approach, but it's also the AES ECB mode, and the third one is how to use the CBC mode in Python. Yeah, so this is the first one, the simple approach. Last we can see we include the crypto module from the AES. Include the AES module from the crypto, and then we have a general function, which is our main function. We have a key and a plain text to encrypt in line 5 and line 6. So in the line 7, we have cipher. We initialize an object called cipher. We use the AES module to initialize it, and we specify that it's an ECB mode. And then it's easy to code cipher.encrypt in line 8 to encrypt the plain text. Well, as you can see, there's a note in the line 6. We have to be a 16 byte or be able to divide by 16 and to encrypt the text. And so you can see in the yellow box, there is an output of this program. It shows the encrypted plain text. And then we can go on to the next example. So different between the one before is that in this example, we can encrypt any length of the message. In the line 4, we now no longer 16 bytes, we have more bytes than 16. But how do we do that? We need a padding function. So we need to add some special character into maybe 32 bytes so we can encrypt that. So that's why we have a pad function in the line 7. We add some open bracket in the end of the text. And so when we encrypt that in the line 10, we can encrypt the whole appended message, and when we decrypt that, we can just remove those appended character. So as you can see from the yellow box, there is an output example. We still have a correct output from the console, shows the correct message. And then we have a third example here, which is AES CBC mode. You can see from the line 13, we still use the AES module, but in this time we use a different mode. We specify the mode CBC to encrypt our data. And also there's one more difference between the ECB mode is that we need another value called initialization vector, which is added to the first block of the plain text before encryption, and the resultant ciphertext is added to the next block of the plain text before encryption, and so on. So we need that information, so we need to encrypt all those information together. So that's why we include the JSON module in the line 17, and we encrypt whole information, including the ciphertext and also the IV. And when we decrypt that, we need to extract the IV from the line 23, and also extract the ciphertext from the line 24. And so you can see the output dark yellow box, you can see this. We can decrypt the encrypt message, and also see the IV and the ciphertext. And next. Okay, so that's a symmetric encryption. And now we are going to show you an example of a asymmetric encryption called RSA. So what we will do here is we will first of all generate the private key using Python, and then we will generate public key from the private key we just generated. And then we encrypt the message with the public key and decrypt the encrypt message using the private key. So the next slide, we will see we include the RSA module from the crypto module, and then we call the generate private key method here. And in the line 10, we write the private key into the file system. And also in the line 17, we use the RSA module again to import the private key. And then in the line 18, we generate a public key from the private key. And in the line 20, we save this public key into the file system again. So now we have private key and the public key both in our file system. And in the next slide, since we have public key and the private key, we can encrypt the message. So in the line 5, we import the public key, and also in the line 7, we encrypt the message with the public key and return the encrypted message. And in the line 12, we pass in the encrypted message into our decrypt function, and we use our private key to decrypt that. And the rest is very similar to the encryption part. So after we run this command, the console line will just print the encryption was correct. So that's my part of the RSA encryption. So next slide. Yeah. Thank you, everyone.
Great. Thank you so much, Omkar and Joe. This was very insightful to see, on the one hand, an overview on the practical, but also the theoretical part on encryption modes and how you can actually code it in Python. We are also happy to share these code examples and the presentation after the event. Just drop your email in the YouTube chat, please. And then we can distribute the slides to everyone who's interested in just recapping the topics from today. So now let's dive into actual video conferencing tools used today, and discover a bit what kind of encryption modes do they provide or do they use. We will go over or present 5 different video conferencing tools. I will be presenting as well as Chitra, and we will cover Zoom, Google Meet, Jitsi Meet, as well as Skype and WebEx. So on Zoom, I wanted to give an overview of the 3 video conferencing tools quickly before I dive into Zoom. If you could go 1 slide back. Great. So I guess most of you know already Zoom. It's a video conferencing platform that got a lot of traction this year with everyone starting to work from home, and everyone moved online remotely. So Zoom currently has a market share of 35% and actually really boomed in their customer acquisition to the whole the COVID situation. With this also some, of course, difficulties arise, such as security question on the platform, but I will dive into some of these details in a bit. Gmeet is also a quite popular video conferencing tool. It was launched in 2017 when it was, or when it replaced actually Google Hangouts as well as the Google Chat. It's featured in the G Suite, and it can be connected to your Google Calendar, of course. A nice feature that Google Meet offers is real-time closed captioning based on speech recognition. I think, or as far as I know, this is the only conferencing tool that offers this service, or at least the tools I'm using. It works well. I don't use it for every call, but it's a quite nice tool to have. And the third option or tool I want to present is Jitsi Meet. And this might be not very well known for everyone in the audience yet, but a very important or also on the rise video conferencing tool we want to promote and explain further in today's call, in today's meeting. It's different than Zoom and Google Meet. It's an open source project. So Jitsi Meet, the project itself started in 2014. It's a web conferencing application. And since it's open source, it has quite a focus on a private and secure design. So an interesting feature that Jitsi Meet offers is the meeting rooms that you can create on the fly, but these meeting rooms are ephemeral, so they actually all get deleted after the meeting ends. And in 2020, this year, Jitsi Meet also surpassed the 10 million monthly user number, so that's quite remarkable. Great, so let's dive into the encryption modes used by these three video conferencing tools. On Zoom, I want to mention that Zoom actually made a quite smart move back in May this year, because again, as I said, the customer base was increasing. Some security issues were discovered in the Zoom platform where Zoom was not very prepared for. However, they did a smart move and acquired actually a startup called Keybase, which is focused on secure messaging and file sharing. And then I think around March, Zoom also published a security plan, how they actually want to tackle or lay out their security. It's publicly available for everyone who's interested in just looking into some details, what's on Zoom's roadmap on the security side. It's very interesting to read. Yeah, some information here. I want to highlight one quick hack, or one hack that actually happened around 2 weeks ago, which was around, or is dependent to the secured meeting rooms, where Zoom's meeting rooms or meetings are actually protected by a six-digit numeric password. However, these passwords could be hacked, and the hacker actually discovered a vulnerability in Zoom's web client that allowed checking if a password is correct for a meeting. And this was based on a broken CSRF or CSRF and no rate limiting. So he actually tried some attempts here and could hack a private meeting, which was supposed to be secured by a password. However, Zoom reacted very quickly on this hacking attack. It's not, you cannot hack private meetings anymore. They actually changed now that a user has to log in with their account details, as well as default password is non-numeric and a longer version. So just on latest text here and how actually nicely Zoom reacted on these attacks. So Zoom itself, it encrypts all public data streams. Therefore, it uses TLS as well as AES 256 encryption to protect the signaling, and as well as AES 228 to protect streaming media. In their security plan, they laid out about a pre-stream key, which is, I think, in development. This would be combining with a per meeting key and with non-secret stream ID using an HMAC function. So each stream key is used to actually encrypt audio and video packets using the AES GCM mode. On Google Meet, we have also some information on the encryption. Google actually ensures security and privacy by encrypting all data in transit by default between the client and Google for video meetings on the web browser, as well as on Android and Apple devices. They even have Google Meeting Room hardware. So this all the meetings hosted on this hardware is also encrypted. Interesting that also all the recordings or Meet recordings, when you have a meeting recorded such as this one, stored in your Google Drive, will be encrypted at rest by default. And also Google Meet adheres the IETF security standards for the DTLS and the SRTP, which provides confidentiality, authentication, and replay attack protection to RTP traffic. Jitsi Meet, I explained a bit before that it's different in terms that it's an open source project. So everyone can contribute to actually the code of a Jitsi Meet. So that's why it has gained a lot of traction in the developer community. And again, focuses also more on the privacy and the security for their users. Jitsi offers by now a so-called hop by hop encryption, which stages of a video call is encrypted in parts. This, of course, is not the, or let's say the final solution Jitsi wants to offer in encryption. There is an end-to-end encryption in work in progress on their beta version. We actually were lucky to test it and to show it. However, we cannot show it today because there were some changes in the web application, but we have some screenshots on how it actually would look like. And Reza will explain this in his part later on. And Levon will also go more in detail into the security setup on Jitsi Meet in detail. Right, so the end-to-end encryption will be provided in specific browsers. They are listed here: Google Chrome, Brave browser, Opera, for example, in beta version as of now. Great, and now I'm handing over to Chitra, who will continue on Skype and WebEx.
Hi guys, next slide please. So I'm going to talk about a couple of mainstream video conferencing tools that we've been using over the years and how they've evolved in terms of technology and security. So starting with Skype, it is one of, obviously we all know that it's the holy grail of communication between our parents, or it used to be, which translated to FaceTime later. So Skype is one of the most affordable entry-level meeting tools or a video conferencing tool available on the market right now. So the type of encryption that is actually used is secure RTP, or a profile of real-time transport protocol that provides confidentiality, authentication, or replay attack protection. The mediation server can also support encryption to the media gateway, but it should also support storage for the certificate. So essentially, it uses TLS and MTLS, transport layer security and mutual transport layer security, to encrypt instant messages, all server to server traffic, regardless of whether traffic is confined to the internal network or which crosses the internal network perimeter. So when connecting to Skype for business in general, the server to the third party IP PBX, which actually acts as a gatekeeper outside, and it is actually used to exchange information essentially. So TLS is optional but strongly recommended between the mediation server and mediation gateway. So if the transport layer security is configured in this link, the MTLS is actually required. Therefore, the gateway should be configured with the certificate and is trusted by the mediation server. So that's how it kind of works on a high level. Next slide, please. So I kind of have a table of different type of traffic and how what kind of security layer it is protected by. I would like to speak about the last row because that's what we use in this day and age. So HTTPS, Hypertext Transfer Protocol. So in terms of content download, downloading address, distribution, group expansion, etc., it's protected by HTTPS, also used in a lot of other tools and our day-to-day. Next slide, please. So if you can move, next slide. So Cisco WebEx is another commonly used tool, and it combines desktop sharing through a web browser with phone conferencing and video. So it is a better version of Skype, but it's also free in terms of basic usage, so everyone can see the same thing. You can save time and money in terms of travel, like how we all are utilizing video conferencing tool as of today given the pandemic. You can collaborate in real time, and you can actually keep track of conversations and decisions, or it has a bunch of cool stuff like recording and screen sharing, just like any other video conferencing app. Next slide, please. So when it comes to encryption around WebEx, it is ISO certified, just like any other vendor. It actually allows WebEx applications to integrate with existing multi-layer security. So Cisco has a value proposition around having a bunch of security layers or like a layering model that is used in Cisco's core application or infrastructure. So a little bit about it. So they they make security, or their whole value proposition is around priority and design, development, deployment around security, and the maintenance of its networks, platforms, and applications as a whole. So you can actually, it's easy to integrate and incorporate WebEx into business processes with the end-to-end encryption. So WebEx also supports a secure cryptography method called protecting data at rest, which is where Cisco stores meetings and user critical data for the business in general. It also uses HTTPS just like any other tool to encrypt data in transit between the device and servers, which also protects the identities of both the senders and receivers, basically providing the basic, minimum basic in terms of information and like how information is actually being captured and not being communicated elsewhere. So Cisco's end-to-end encryption uses AES 128, AES 256, SHA-256, and RSA. So for any type of audio, video, or screen sharing, Cisco encrypts content using an SRTP or a secure real-time transport protocol. So it also stores passwords using SHA-2. It also encrypts all ad hoc passwords, and which is used for meetings or recording. So every video conferencing tool provides like a custom password in terms of a private meeting, but you also have the ability to make your own custom passwords, which is also being stored. So it also encrypts stored network-based recordings. Next slide, please. So in terms of password, right, different IT teams can also add features that use existing security policies like SSO, which has become such an industry standard right now, or single sign-on, or synchronizing teams with employee directories. So it's a very good feature because even Microsoft has enabled Teams or Skype for Business into the employee directories. So WebEx, they automatically recognize if someone has left a company. So they understand that, and they kill the user credentials so that nobody's stealing data. So any company can configure WebEx team. So all it just requires is password authentication to match the corporate security standards that any company has, and it differs. The teams, they also support identity providers that actually use security assertion markup language, which is SAML integration, SAML 2.0, and OAuth, which is open authorization 2.0 protocols. Next slide, please. So I have a high-level diagram of the multi-layer security model that Cisco considers its value proposition, and it's sliced into three major areas, one being application security, the second being data center security, and the third being security and trust. So the first application security layer actually consists of cryptography, administrative controls, and end-user controls. And the data center security consists of physical security, infrastructure, and platform security. And this is also layered by tools, processes to securely develop and operate structure to install security in the DNA of the company. So that's about it. Next slide, please. So I'll have my colleague Abdul Karim talk about authentication flows. Thank you.
Great, thank you so much, Shidra. Before we hand over to Abdul Karim, I just want to highlight again the backgrounds also of our students here. We have really high-level, very in-depth students. I said 7 students in our class presenting today from software engineer, network engineer, cybersecurity background. So it's just always very, very fun to work together, to learn together, and especially to get taught and learn from our Professor Dr. Mamoon. So I just want to highlight this again, and also the diversity of our of the backgrounds from our students. Now we are diving into authentication. Omkar has presented on this beforehand and actually explained how important authentication also is in encryption and security for video conferencing. And I'm handing over to Abdul Karim.
Hello, everyone. My name is Abdul Karim, and let's dive deep into JWT. So JWT, what is JWT? JWT technically is one of the most widely used standard across all the modern web applications and mobile applications, ranging from user authentication and invoking REST APIs to transfer information between applications and resource servers. So JWT is an open standard that was created to handle client authentication and authorization. By authentication, you're talking about identifying whether a user is who he is claiming to be, and by authorization, we are identifying whether the user has all the right uh, roles assigned to him in order to access certain resources, certain secure resources. And if we look at how JWT is used to achieve this authentication and authorization is by exchanging information between two entities. Usually these two entities are authentication server and the client. Technically, what the authentication server does is it issues a JWT, which is nothing but a JSON web token, or we usually refer to JWT as a JOT. So this token is nothing but a very long encoded string, and this encoded string is decoded on the client side, and and claims are extracted from this token. And I have highly referred to the JWT as a long string, but if you take a look at what JWT is, you can see on my screen, it's a really long string which is concatenated with each other. If you take a deeper look at this string, you can see the string has three different colors, and each different color identifies a specific part of that JWT. The first part you can see is highlighted in red. It's separated by the second part through a period, and the last part, which is in a different color, again is separated through a period. So let's see what that each part denotes. So the first part is header. Basically, the header contains the necessary information about what type of algorithm was used when preparing this JWT, as well as what type of token that is. Basically, we have two different types of authentication tokens. One is an access token, which is relatively smaller in size, and the other one is the longer version of it, the JWT, which you see on the screen. The reason why JWT is such long is briefly because it contains a lot of information within it, which when the client decodes on the client side, he'll receive a lot of claims from it. Levon will be going through in detail what those parts are. And the last part of the JWT was the signature, which is used to actually verify whether the sender is who they are claiming to be. And moving to the next slide, we have spoken that JWT contains a payload. Now, what that payload contains. So payload is contains nothing but claims. These are the pieces of information which a client application receives, and the client application sends this information to the resource server. Basically, whenever a client is preparing a request to a resource, for example, an HTTP request to fetch certain resources from resource server, the client updates that HTTP request by adding JWT as a header information. So few of the claims that we go over here are audience, AUD, denoted by audience. Basically, what audience is that it identifies who the intended recipient of a token is. For example, application A requests for a JWT, then the audience field will include information for application A. The significance of this claim is that a claim which was issued for one application cannot be used by any other application. If any other application, like for example, XYZ is trying to use a JOT which was issued for application A, then the resource server rejects the JWT. The second claim that we go over here is issuer. issuer identifies which entity or principal issued this JWT. Most often, this issuer will be the authentication server, which is hosted in-house. And the third claim is the subject. Subject identifies the entity to whom JWT belongs to. For an example, if I as a user tries to authenticate myself and I am issued a JWT, now I am the subject of that JWT. And in the context of the issuer, every single subject should be unique. No two subjects can be sharing the same details. So that is actually how users are differentiated on the basis of JWT. The third critical claim is expiry, and this is very configurable claim. What expiry does is, for an example, when I as a user authenticated myself and I got a JWT, I cannot use this JWT after, say, for X number of days, because my JWT is expired. So we always want to keep continuously keeping on users authenticated, and we keep on issuing the most updated JWT. Not updated in the sense, but we keep on validating. We follow the policy of trust no one. So every single time somebody has to request a resource, then we have to pass on JWT to. So by using this expiry claim, we can make sure that whatever JDOT is used, it's unexpired. And issued at is another claim that can be used to offload the JWT verification to the client server, to the client application server. Basically, how it differs from expiry is that if an application, or if I as a developer specifically specify that I want to expire out a JWT after 2 hours it was issued, I can make use of the issue date claim. Whereas my expiry can still be like 2 days, but if my issue date is set for 2 hours, it will my application server will straight away reject it out. And if we take a very brief look at the Python code for encoding and decoding the JOTs. So the library, the Python library that we are using here is PyJot, and you can see that this program has 2 critical components. The first component being the payload, in which we are specifying audience issuers, subject, context. Context basically contains any necessary information that the client application might be needing, and then we are also passing out roles for authorization need be, and issue date and expiry. So that is my payload. And then I am invoking on line number 22, you can see that I'm invoking the encode method of the JOT library to actually prepare the JOT. And I'm passing payload as a parameter, secret, algorithm type, and the headers. And let's move to the next slide. So once in the previous slide, we have covered creating a JOT. Now, if I want to decode this JOT, I can straightforward make use of the decode method from the JOT library. Basically, I'll be passing whatever JOT was created, and I'll be passing the same secret to it. I'll be specifying the algorithm. If at all my JOT has expired, or if at all the claims were not true, then my decode method straight away throws an error. It identifies that the JDOT is not a valid one, it's expired. Technically, you can request again to issue a new JOT through an authentication flow. We will be going over the authentication flow in the next slide and see how a client requests an authentication server for a JDOT, and how a client makes use of this JDOT whenever it wants to request some resources. So in this block diagram, we can see that there are 4 areas, four primary areas. One is client, the other one is browser, and the third one is authentication server, and the fourth one is resource server. Remember that resource server is the server which is having access to any business logic or any data that the application might be storing. So we begin with the client side. Client is nothing but an application. It can be a web application or it can be a mobile application. So a client application, let's see the arrow that is marked as 1. So the client makes use of the browser to contact the authentication server. Basically, the client wants to establish its authenticity and wants to get all the credentials, the roles, the authorization roles. So the browser requests the authentication server, and then the authentication server responds with a secure login page, and the user is presented with this login page. The user enters his username and password on this secure page and directs the information to the authentication server. And in the 5th arrow, we see that the authentication server verifies these credentials, and if the credentials are valid, if the user has successfully established authenticity, it generates a JOT and sends back to the browser. And under the arrow 6, we can see that once the browser has received the JOT, it will pass down the JOT to client, and client, whenever it wants to request for any secure resources, it will make an HTTP call to resource server. So client prepares this HTTP call, and to this call, it appends my JOT in the request headers, prepares the request, and through the browser, we can see that arrow number 8, it dispatches the data request to the resource server. On arrow 9, we can see that once the resource server has received this HTTP call, it extracts the JOT from the header, validates that JOT, and identifies whether the user first identifies whether it's an expired JOT or not. Second, if it's not expired, it checks whether the user has access to these resources that are being requested. If the authorization have passed, this resource server extracts the necessary information from the database or any resource storage endpoint, and then it responds to that data request and sends back the HTTP response back to the browser, and from browser back to the client. So this is how the JDOT on a very high level is created and used between client and resource server. Now I'll hand over to Reza, who will be carrying forward the presentation. Thank you all.
Yeah, thank you so much, Abdul Karim. Authentication, again, is a very hot topic, but very important also to understand. So thank you so much to explain the overall flow. And as you said, you're our authentication expert in class. So thank you so much again. We now have 2 speakers left for the end of this presentation. Reza and Levon, both of them will actually explain more in depth, explain about Jitsi video conferencing. First, Reza will start to explain the end-to-end encryption used by Jitsi Meet and explain it on a demo, how it would look like, and then hand over to Levon, who will have a real demo on our Jitsi Meet server we have set up, as well as all the security implementation we have done so far. Reza, your turn.
Okay, thank you so much. Hi, everyone. First of all, I would like to appreciate for being with us over here for such a wonderful event. And I want to appreciate Dr. Mamoun and my classmates for this wonderful work and collaboration. So without further ado, let's start. I'm going to talk about the real example on Jitsi. So how we can prepare and with a few virtual examples that we have. So as my classmate talked about end-to-end encryption before in different application on Jitsi, there are 2 ways that we can run the end-to-end encryption. So one of them is peer-to-peer, P2P, which is going to be happen over Jitsi video bridge, or they call it JBB. So it's going to be only for one-to-one meeting, and in this case, audio and video are encrypted using the DTLS and SRTP, and all the way from sender to a receiver. So the the SRTP is just a framework for establishing the secure real-time transport protocol, and the DTLS that we are using is a context using the datagram transport layer security. And the second way over here is for the few people, just they call it like multi-party meeting. So all audio and video traffic is still encrypted on the network. So again, using the same mode, which is the DTLS and SRTP. Next slide, please. Yeah. So on Jitsi, as Zoe mentioned before, we are able to enable end-to-end encryption. So, but at the moment, we are not going to do any example about this, but we have some virtual example. But just the point is, when we are opening the application on Jitsi, we are able to provide any key, any password. So, and it can run as an end-to-end encryption. Next slide, please. Yeah, so as an example for E2E encryption, so let's say we have few people on the call, and the last person, or is trying to join to the call. So because the video has been already established in secure mode, so the fourth person or the third person, once they join to the meeting, they cannot hear or see anything. So they just stay seeing some rubbish screen. If you go to the next screen, yeah, so as you can see here, the fourth person is just joined because they don't have any password, they don't have any key, they cannot see anything. So this is the example of E2E or encryption mode in Jitsi. So once the rest of the party, the rest of the people, they provide a password for the fourth person, they can see the fourth person can join to the meeting and can participate, can just watch the video and listening to the people. So the point was how that end-to-end encryption is a big point and highlighted in Jitsi. So how does all this work? So as we talked earlier, in most of the application and mostly that we are talking about Jitsi, is protected by secure username and password. So however we can define those, we can make a room as example, room name or any class name, whatever, plus a password. So as we mentioned, in this puzzle that we put all the DTLS and SRTP in WebRTC, so it's all strictly tied together in the peer connection, which means when using when we have a video router like Jitsi, when it's involved, the WebRTC and DTLS and SRTP can only provide hop-by-hop encryption, as we mentioned this one before. So this is what protect all the data on network. So in order from media from one participant to reach another, so we need to extract from the sender crypto context and re-encrypt it with the receiver. So in order to establish hop by hop. So here is a quick brief and example about hop by hop in Jitsi. So as you can see over here, so it's going to decrypt the information while it's just crossed to the video bridge. So is going to provide whoever controls the JBB machine, so which is the Jitsi. So, and is going to make the opportunity to access to the data. So, meaning to providing the password for the rest of the people in the meeting. So, and then once all this has been established in hop by hop encryption or mode rather, so then everybody can hear and see each other in the meeting. And the next one, as we pointed earlier, is end-to-end encryption. So it has been a few years that the privacy enhanced RTP conferencing that they are all working on this to make a new design and transfer the extra layer of security on video conferencing. As an example, like a Jitsi. So so they call it E2E, and how it worked exactly on WebRTC conference. So this is just like better idea to being some weak password or authentication and in DTLS and SRTP implementation. So as I mentioned, so it's going to add the additional layer of security in our conferencing, and is going to be on top of the existing security layer that we have. So as example, if we have hop by hop, so we can add the additional layer of security, which is end-to-end encryption. So from here, I will hand it over to my colleagues and classmate, Levin, and he's going to talk more about this. Thank you so much, everyone.
Hello, everyone. I guess I'm going to cover the rest of them slides. Let's start. First of all, kind of what we're going to cover here. We're going to cover well, basically public keys which are used for SSH. We will basically run through the setup of the server to some extent. I'm not going to cover it very deeply because it's more like admin part rather than security part. But anyway, I'm going to cover fail to ban to protect SSH. After that, I'm going to cover, well, just briefly, it's basically one-liner. Let's Encrypt part. It's a service to provide certificates for the web server. And after that, I'm going to cover a little bit of firewalls. I'm going to cover practical part of JWT tokens. And I'm going to cover fail to ban in terms of protecting our own authentication part, which we will handle with our code. So SSH public keys, it's actually pretty simple and straightforward. I guess probably almost everybody is familiar with it, but in Unix-like systems, you can basically use SSH keygen utility, which basically generates you a new set of keys, public and private. In Windows, you can use something like PuTTyGen, pretty much the same, but with GUI. To copy it, either use SCP in Unix-like systems, or use WinSCP, which is again GUI utility in Windows. One thing, I don't remember the name from the top of my head, but there is an utility that in Linux basically allows you to copy the key to the target system in one line. Okay, one thing, don't forget to disable password-based authentication. I've shared the line in the bottom. Password authentication, no. Set it to no in etc ssh deconfig. Also, Let's Encrypt. With Let's Encrypt, it's pretty straightforward. Once we install Zoom with Jitsi, we already have the script pre-shared with us, and we basically just invoke the line I shared, and that's pretty much it. In worst case scenario, what could have happened, you might need to install certbot, but that's pretty much it. Fail to ban. This part is basically out of the box part. You just install fail to ban. I've just shared a few snippets of a few commands, like the ones you want to invoke. So basically install it, copy the configuration to jail const to jail local, edit it, and after that, basically in the configuration, set enabled to true in SSHD section. Firewall. Right now, I'm showing a screenshot from Amazon's firewall configuration. Personally, I don't really like it because it does not really have a lot of options. It basically is not stateful, but anyway, it's better than nothing. So we are going to open port 22 We probably don't want to open it to everyone. If we have a whitelist, it's better. If we don't, well, then in my case, it's any IP address. We obviously want to enable HTTP and HTTPS. Well, if anybody tries to reach us through HTTP, we are basically going to send them to HTTPS, but we still want to enable the protocol to at least accept the queries. And Jitsi also wants port UDP port 10,000, which is going to take care of the media. Next one is the operating system firewall. We were using Debian as a operating system for our demo, but you basically can use Ubuntu, you can use CentOS, whatever flavor of Linux you like, just use it. So for Debian, you'll have to install iptables persistent package. For Ubuntu, you will have to use UFW, but basically they're pretty much the same. So the way it looks like, don't forget to block everything that is not required. So basically your rule of thumb is going to be input drop. We don't care about forward because we're not a router. Then we actually have to allow some certain ports. So the next line basically shows you how to add a port to the allowed list. The first one actually is going to be applied after everything, because -p option basically tells like the default rule is this one. Fail to ban will also appear in the IP tables. So don't get confused. You will see those rules, and it depends on how many jails do you have. And fail to ban, you will basically see those ones in the IP tables config. Okay, next one, a local authentication. Let's say we already installed Jitsi, and basically, quite honestly, is just add the source to Aptitude or to Yum or your packet manager, and just basically issue a command to install it. And let's say you have your Jitsi up and running, but you don't really want it to be available to everyone. You want only your company, school, whoever, your friends to use it. You don't want a complete stranger to get into it. So you probably want to introduce some kind of authentication. Basically, it's done through prosody module, and we're going to deal with prosody here. So basically, you have to edit prosody configuration in configuration available directory, and the file name is going to be the domain name that you defined when you installed Jitsi. So what you want to do, you want to change authentication to internal plane. And also you want to add guest virtual host and allow anonymous access, because otherwise there would be no way for the guest to get into your Jitsi system and basically enter the password. Next one, you want to add anonymous domain to Jitsi Meet configuration. And that's basically how you do it. That's the middle part of the slide. The last thing, you want to add this line to SIP communicator properties. Again, replace our domain name with your domain name. So again, after doing everything, you want to restart pretty much everything. Toughest part here, you have to create users over the command line. And if you're a small company, if you're sharing Jitsi with your friends, that's fine. But if you're an enterprise, you probably don't want to create a user every single time, and you don't want to go into the command line every single time somebody wants to create a user. So that's not too flexible, let's just say. But here is the command how you do it. So if you're satisfied, you basically can drop for like next 5 to 10 minutes because I'm going to cover token authentication. So the token authentication is going to involve some amount of witchcraft. First of all, Lua Crypto does not work with libSSL 1.1. At least it didn't work when we installed them demo. So we had to downgrade to 1.0. Also, we want to install additional packet, Jitsi meet tokens, generate application ID and a secret. Basically, just get any password generator and you're done with it. I mean, it's just a long enough string. Don't do it 1, 2, 3. Obviously, you want it to be secure. Add application ID, app ID equals your ID that you generated, and app secret equals your secret that you just generated, and authentication equals token to the virtual host your domain section, the one I showed 2 slides before. So instead of internal plane, it has to be domain, it has to be token, and basically also add these 2 lines. Make sure that token verification is enabled under component conference JIT-meet example, well, conference JIT-meet example.com MUC section, but well, obviously it's going to be your domain, not JIT-meet. In our case, it was our domain. So I quite honestly didn't copy it from the real file. One thing I wanted to cover before going a little bit into practice is Decrypt. Basically, Blowfish also can be used for hashing, not only for encryption. Decrypt is the Python module that can be used for dealing with Blowfish stuff. And the first line basically shows you the hash itself. So the first part between $signs is basically the algorithm that is used. The current one, I believe, is 2B. The next one is the cost, like 2 to the power of 12. The next part, I believe it was 22 characters, is the salt. And the last part is basically the hash itself. So in Python, basically import Decrypt, create a salt, and the line that is hash equals bycrypt is basically the creation of the hash. It's that simple, just 3 lines: import, create salt, create hash. To check the password, Decrypt offers basically one-liner. You feed the candidate password, the one you want to check, and you feed the hash code to the module, and it basically gives you true or false. If it's true, then obviously everything is fine. If false, well, guess what? Somebody will not get his token today. After that, you see basically the output of MySQL. That's how the database entry looks like for my current user. Don't try to break the hash. It's basically super password, and I'm not afraid to share that one. Obviously, my passwords are a little bit more secure, but anyway. So basically, we have the hash here. We have login name, and we have first name and last name that we're going to use in our JWT when we will create it. So as Abdul Karim already mentioned, that's how you create the token. So in our case for Jitsi, we need to issue audience. We need to mention audience. We need to mention the issuer. And in my particular case, I basically made it the same application ID since we are generating everything on the very same server. But in Jitsi, basically, you can select like, I don't want to accept anything for this audience. I don't want to accept anything from this issuer. Well, basically, it actually is whitelist based. So you say like, okay, fine, I want to only get stuff from this guy. Also, we're mentioning our own address of the Jitsi server. Expiration, just in case it's in its Unix epoch. So I'll just use that format. And we also want to pass the room to Jitsi. The room variable basically defines the room that can be accessed by the presenter of the token. So basically, the whole thing looks like import JWT. If the password works, create the token, then encode the, well, if the password works, create the, well, not the token, but the content, then encode the token, the content into a token using algorithm, specified algorithm, and using the secret, which we are grabbing from an external module, which is separately populated with secrets. After that, we want to start an HTTP server using the very same Python simple HTTP server. And I'm going to serve regular HTTP because I'm going to handle all the HTTPS stuff to Nginx. So we're starting a server which is going to check if there is a token. Basically, we're sending the proposed password to the module we described earlier, and if the password is correct, we will get a token. Otherwise, we will get none. So we're checking if we got a token. If we got it, we're basically sending a 301 response, which basically means, okay, look somewhere else. Sending the client to the very same our server, but with the room name and with the token. And basically, the last line is the server creation, and then after that, it would be like while true serve forever. Okay, a little bit tough part, fail to ban for JWT authentication. First things first, we want to let fail to ban know what's the IP address, because otherwise it will not be able to block anything. It will block 127.0.1 because by default Nginx will send localhost to the server. So in Nginx, we want to add X forwarded for header, and that's the line. How do you add it? Then in the code, and the in the token creation code, you want to basically write the logs every single time a fail occurs, and don't forget to write a timestamp, because otherwise fail to ban will not be able to work with it. Then after that, you basically define the jail and the filter in fail to ban configuration, and that's how the jail looks like. Basically, name, enabled, ports that you want to cover, and those ports would be blocked if somebody basically crosses the line and tries to brute force you, and the filter to use, and the log that you are going to monitor. By the way, don't forget to, if you just created the thing, don't forget to touch the log. Otherwise, if the file is not there, basically fail to ban is going to crash, and it's going to complain in your logs. Filter, that's how you want to create a filter. By the way, you basically want to know a little bit about regex. Otherwise, you're going to have hard time working with it. Also, the way how you basically format it: definition section, then failed regex, the way you basically want it to be, And in my case, I simply do timestamp, then word fail, colon, and the next after a space there would be an IP address, and that's the format how fail to ban expects it. The log code, basically that's the code you want to add to your token creation. Well, open the file, write the line, and basically that's pretty much it. And the last line takes care of the forwarded headers. Okay, that's how you want it to be in. That's how you want it to be in Nginx. Nginx, in Nginx, basically edit the file that is responsible for your config. Then don't forget to also escape the login page, the one that is going to be kind of like static. So that's basically the config in Nginx. By default, we're sending everybody to this login page. I'm going to show it in the demo section. After that, we're saying, OK, fine, for JAuth, that's the folder I'm using for our authentication part, pass everything to the server, to the Python server. And don't forget about this x forwarded for line. The trick is there are two values. We actually care about the real IP of the proxy. We don't really care who is the real recipient. If proxy basically sends us brute force, then we don't want to listen to the proxy. So OK, that's part of the Nginx. The next session would be Q&A section. But before that, I was going to show you a few real examples. First of all, Abdul Karim covered the way the token looks like. I wanted to cover a little bit of it, basically how the thing changes if you change something. So let's start with the signature, because that's the easiest part to cover. When we change it, only the last part changes in the token, this one. It basically is the signature that says like it's created out of the secret and out of everything else in the token, like the header and the payload. So if you change the shared secret, the secret, the only signature is going to change. Now, if you change anything in the payload, let's delete a few digits here. You see that the payload changed, the signature changed because signature depends on both payload and the secret, but the header stayed the same. So basically, this part has nothing to do with the second part. But if we change the header, let's say, I don't know, well, OK, fine, it's not going to do this, but let's change the type. The algorithm is basically important, so yeah, don't change that blindly. Let's change the type. Once I change the type, the header changed, the signature changed, but the payload part did not. It's still E, Y, J, and whatever. So that's what I wanted to share on the JWT part. Now let's go to demo. That's basically how our login page looks like. Here is our page, and you can see it's HTTPS by the basically this padlock, and as you can see, it's issued by Let's Encrypt to our domain. Anyway, I'm going to log in as me. We have only me, and I'm going to enter the password and the room name. And if I did not forget my password, it's going to let me in, and it is. And if you will make it on time, you will see that it actually had the token in the URL, but after that it disappeared in a bit. Here is the link that you can share with your friends, and basically you probably want to add a password, otherwise anybody would be able to join. I'm going to add a simple password, which is 1234. And basically now I'm in the session, and you can see my face both in the corner and in the meeting, though the one in the meeting is a little bit blurry because, as you can see, it's LD, which stands for low definition. One thing I wanted to cover here, I had to jump from 1 core and 512 megabytes to 4 cores in Amazon's instance, just because I didn't want to, well, first of all, with 1 core and 512, it basically crashed occasionally. So give it a little bit more juice. And also what I wanted to demonstrate, I'm going to use my other laptop. And let me join my own session. And if I did not make any mistake, you are going to see 2 faces, and my face from a different perspective once I'll enter the password. And also Jitsi could be one important thing here, don't forget to turn off the microphone, otherwise you are going to get the audio loop. And also Jitsi can be used on the phone. So there is basically an application for that called Jitsi Meet. You can download it in App Store. And I'm going to demonstrate the third version of my face and log in through my phone. Basically, you can, no, that's another face. Basically, what you can do is you can set up your own. You can set up your own Jitsi server, set up some kind of authentication. And the trick is, in our example, I used the server itself as an authentication entity. But technically, you can, the reason I was showing the code, you can refer it to some external authentication source, like some external application with a user database, and basically get the response from it. Is the username or password valid or not? And if it is, then you basically can generate a token and do whatever you want. You can also grab some data from this application. As I showed before on this slide, I basically had this first name and last name. It's being encoded into this one. Basically, the application generates a full name from first name and last name and passes it to Jitsi. So the person will not have to set up his first name and last name in the chat window. So basically, you can refer the thing to the external application. That's, I believe, it from my end. So I'm going to pass it to Zoe, and she's probably going to cover the rest of it.
Yeah, thank you so much, Levon. This is always super exciting to see a live demo, and especially everything to see how Jitsi actually really works with our server setup. So first of all, thank you for the detailed knowledge you've shared and the real-time demo. I also wanted to thank you, our professor, Dr. Mamoun Samaha, again, for really pushing us always in his classes to be our best, to present our best. And that's why we also created this event for everyone who joined online today. So we are good in time, actually. We said we want to cover, or we have content to cover for 1.5 hours. Now we have 30 minutes left until 8 p.m. to discuss some questions from the audience. And also thank you to you, everyone who's out there and joining us online, to staying with us, being interested in this topic, and raising some questions, because we have received very good questions in our chat, which I consolidated and will guide to different of our speakers today. Again, you now see our speakers consolidated here on our slide. Professor Mamon introduced himself as well in the beginning. So one question more on the regulation side was raised by Kumal Yoshi, and I just read the question out. Are these security domains audited and reported through SOC1 report? And I think, Abdul Karim, you could comment on this, and who everyone wants to jump in afterwards, please feel free.
Yes, so they can be included in under SOC1, but as well as they can be, actually, I believe they will be a primary part of SOC cybersecurity, because Jitsi can be hosted and managed by the company itself in-house without delegating the services to the third party. So based on that, I think SOC cybersecurity is the right one under which it falls. But if anybody can add something to it, please feel free.
Yeah, I think this makes sense. Kumar, if there are more questions, the question not fully answered, please let us know in the chat, and we will follow up on this in a bit. But let's jump into the next question, and I would hand this one to Reza, as he explained a bit on hop-by-hop encryption in Jitsi. And the question is from Erwin, asking, Jitsi uses hop-by-hop encryption. Assuming I do not have my own server set up for Jitsi, does that mean it's prone to eavesdropping on the server side?
Yes, that is true. So Jitsi has their own server that we can run all the meeting, all the video conferencing by hop-by-hop encryption. But the question was not clear enough. So it depends on what we want to accomplish based on the server. So we host a server or we use a server from the provider, as example, Jitsi.
Great. Also, Erwin, if there are more things to clarify, please let us know in the chat. But I think Reza covered this question very good. Also, follow-up question I would add here, Reza, just if you can stay online quickly, from Alp. Can we achieve an encryption method that is not decrypted in JVB server? Only the client who have the key can access data.
Yes, it's possible. It's possible, but it is important to find a way that the way that they decrypt the key that we have for the video. But yeah, the answer is it's possible, and there are few more ways that we can add additional layer of security on this. So we have to talk more about this in the feature of the Jitsi that we can provide this one, because at the end we were talking about the WebRTC that we can add the additional layer of security on hop-by-hop encryption mode. So this is related to that part as well.
Thank you so much, Reza. The next question raised by Greg, and I would direct this one to Levon, as he really gave us the detailed security setup on Jitsi. The question is, for Jitsi, if you boot someone from a meeting, they have the password so they can rejoin the meeting or monitor. Have you considered how to revoke access to participants?
Okay, so quite honestly, the answer is yes and no. The tough part here is when you create a token, it's basically needed just to start the meeting. So for example, when you enter the Jitsi meeting, it basically, if there is some kind of authentication, it's going to ask you like, it's going to say that the host didn't start the meeting yet. So it's going to basically allow you to say, okay, I'm the host. So if you have a local, authentication, then you will be prompted to enter the password. If you have tokens, then basically you do it through the URL. But the trick here is once the meeting is started, then what protects it is actually the password that you created. And that's the tough part. If the party knows the password, then yes, you probably want to change it. So that's something that, at least that's as far as I know the thing. On the bright side, I know about all the jokes about open source, but still it's open source. You can modify it to some extent. It's not that complex. It does have some underwater rogues, but it's still doable. Though the answer is you will probably have to change the password for the meeting itself. And I don't believe it's going to, I don't think it's going to boot, once you change the password, I don't believe it's going to boot everyone who is inside. So it's the one for joining.
Cool, thank you, Levon. And William, no, this was for Craig. I hope this answer was satisfying. The next question from William is this tech, and I think you're referring to Jitsi, as we have displayed the demo. Is this the tech that the new platform StreamYard used? Are they similar? This is a very good question, but I'm personally not familiar with StreamYard itself. It would be good to provide some more information, or anyone who wants to jump into this question, please take it from now. Otherwise, we need to follow up on this, William. Okay. Just some a follow-up from Kumar was, yes, thanks a lot for the answer, Abdul Karim. I believe it depends on the service organization if they want to include these domains. Yeah, that's a good comment here. And Erwin also from his question says, thank you, Reza, you are correct. If I were to use the Jitsi server, since I do not have my own server set up to be able to use Jitsi. Yeah, great. I think these were all the questions by now. If there are more questions, please send them to the chat. We are still online for some minutes. But if there are no further questions, we are enjoying the online event for some further moments. I would also like to hand over to Professor Dr. Mamoon actually for last words, and yeah, give over to you.
Well, one more thing to add, Zoe. I just checked the, I mean, talking about the question I answered, I just checked, and yes, you basically can change the password. It's not going to kick anybody else. So the idea is to change the password on the fly.
Great. Thank you so much for the follow-up, Levon.
Thank you, Levon. Thank you, everybody. This was outstanding work in a very, very short time during one course and one small project. It was a fraction of a project. So it wasn't a capstone or anything. It was just one assignment for you. So you did outstanding job. I know most of you never worked on the end-to-end security and video, and the learning was outstanding. So thank you so much. I want just to give you a background. We got into this assignment in 2 classes, capstone as well as your projects, because our President Yao wanted us to start exploring this ourselves. So our President Yao said, I want you to include this in various points because of security issues. We want to have our own solutions and explore. So thanks to the President, to Yao. Also, the reason I looked at at video conferencing. I was teaching Android regularly online and for the last couple of years, and I needed video conferencing, and I was monitoring my mentor, Phil McKinney, and he was always commenting how great is Zoom. So I'm glad you could join us, Phil, and I learned a lot from you. I started doing this for Android, and because you were always supporting them and working on those, and I wanted my students to show you the side of their small project in class. And we did most of the encryption and the networking, and the networking was a part of it. So thank you so much for joining us, and all the mentoring you did for me over the years. So that's why always to be thankful, I always like to share what I have. So thank you. And also, Jahan, thank you for everything as well. Thanks for joining us. Any questions to the audience or to the team?
Nothing from my part. I thought the presentations were quite excellent. As Mamoon said, I've been Eric Ewing, who's the founder and CEO for Zoom, is an old friend of mine. When I was CTO at Hewlett Packard, he was at Cisco. Eric is one of the creators of WebEx. So Zoom was his second attempt. So I was an alpha customer on Zoom, and but some of the discussions today, particularly on the end-to-end encryption and the elevation of privacy, we saw that happen early into the COVID experience with Zoom, and that interest, because Zoom was designed for enterprise, but consumers were quickly gravitating to the tool. It was never designed for consumer usage, but they reacted pretty quickly. But I can tell you, with my current role as the CEO at Cable Labs, we developed the security. One of our roles is setting the security technologies for the broadband networks. So if you like your broadband from Comcast, or being in Silicon Valley, most everything is Comcast. We are the R&D and innovation arm. So encryption and privacy has quickly escalated to being one of the top priorities for our research agenda in the lab. And it's one, is some of your speakers pointed out, it's constantly changing. It's changing quickly. So I would encourage those of you who want to pursue deeper work in this area. There's a lot of opportunity in the research space, but also in the commercial application space. And you never know. We're always looking for top talent in the security space. And Mamoon knows how to get a hold of me.
Thank you so much. Thank you, Phil. We appreciate it. Thank you. And we will definitely be in touch with you for the university if we want to do any of the research or deployments. So thanks a lot. And so thank you so much. I think that's about it. If we don't have online questions, I think we are done online. If anybody want to stay on the Zoom or have other comments, you can stay. Dr. Jahan, if you want to say anything, you could do it publicly, or you just do it after.
I just had a quick comment, or at least question for the guy. Great job, guys. Well done. Especially within the scope of a term project. So well done. It's just a question for you guys. If you want to take what you've implemented as a project to the next step, especially if you think in terms of implementing this as a part of incorporating it into EMS, because there was some discussion of this yesterday. So in terms of testing, what sort of things have you guys done, or what do you think needs to be done in terms of more formal testing of the features you've implemented or demonstrated today?
Well, I guess I'll take the question. So if we're talking about testing, well, first of all, obviously we need to know like what are our inputs and what are our outputs. I mean, like do we have a how are we going to communicate with the EMS, for example, if we're doing that? And if we're talking about just testing the platform itself, I do have, let's say, a few minor questions to the thing. I mean, in terms of Jitsi itself and in terms of configuring it. But that's solvable, I believe. The main test that I would really love to do is load test, because, well, first things first, the thing crashed on me. I know I loaded the server with tons of stuff because I was experimenting with like multiple entities there. And obviously loading one core and 512 megs of memory was a little bit evil thing to do. But we definitely want to get some kind of load testing. Another thing that might be, well, it's not about testing, it's more about configuration. We'll probably, and yeah, we basically want to see how it goes. But if we're also implementing that, we probably want to do like some kind of load balancing and some kind of redundancy, because if we're implementing it in EMS, I guess if one server dies, it's not the best outcome if nobody can have classes anymore. So we probably want to get it done and test a little bit of reliability. I think major part of it goes to Nginx configuration, but still has to be implemented and tested. Those are like the first two things that cross my mind at the moment.
As you're well aware, it's, testing happens at different level. At a developer level, you need unit testing. Then you need to do integration testing, and performance testing is mostly a production level testing. So in my opinion, these sort of things, especially, you need to sort of use the proper tools in order to turn this into a product, basically something that is reliable. You need to do all these testing that I briefly mentioned at all levels, and have a system level testing, end-to-end testing, and then functional testing in terms of try to break it, basically try to break the security. So you need to have the system running on a system, and then try to invade and intrude to the system and see what happens. There are standard also ways of testing. You're familiar with some of them. You probably have seen it in your classes, basically man in the middle attack, and simulate these sort of things so that it's fully tested from the security point and also from software point of view. So I think these are, at least I would recommend that at least you guys look at it. And this is where actually, you see that such a product, it's such a software, in order to turn it into, get it closer to be a product, you need all sorts of skill set, software development skills, security knowledge, and then you have to think about it, deployment, and how to package it as a build, a build software. We cannot just take a copy bunch of files on the server and it's going to start running on its own. So you need to think about how to release this, how to package it, and how to basically go through the build process. So again, there's a lot of software level stuff that needs to be done in order to get this closer to a real product.
Yeah, thanks a lot for the insight. One thing to mention here, since it's open source and it actually is supported by a lot of basically popular companies and big companies, to some extent, the Jitsi part is to some extent tested, even though, as you mentioned, yes, we do want to run security tests, not even mentioning all the software part that you already mentioned before. And with security, I already have like a few things to take a look at. So the thing is more like, you're right, it's more like a proof of concept rather than a ready product. Well, basically it is a demo. As for deployment, yes, obviously we want to take a look at deployment, take a look at flexibility about the way to extend this thing, because obviously like one server is not the way to go, and it has to be, well, some kind of continuous development and deployment cycle has to be implemented. So yeah, there are tons of things to take a look at if we're talking about the enterprise project.
Yeah, good. It doesn't take away what I mentioned from great job you guys have done already. Well done.
Yeah, thank you a lot.
Thank you, Jahan.
Sure.
Yeah, I think if there are no more questions from the audience, and I guess no further questions. Some students have, or some attendees have submitted their emails. You will receive the presentation afterwards. To recap, I'm always happy to come back to ITU's live stream and or yeah, YouTube channel to recap this event as well. Great. Lemon, go ahead.
I'm sorry to interrupt, Zoe. I just wanted to mention, William, you didn't get your answer, your question answered. So could you please share your email so we can follow up with that? The short answer, I don't believe Jitsi is related to the platform you mentioned, but still, could you please share your either email or some other way to communicate with you so we can follow up with your question? Sorry to interrupt again, Zoe.
Guys, if you have questions, send it to cybersecurity@itu.edu, and we will get you an answer on all those questions. Thank you so much for attending on the YouTube channel. If anybody from the team has want to stay on Zoom, stay on Zoom. And I think we are done with the public presentation. I hope this was useful. Again, the cybersecurity@itu.edu, and we'll get back to you if you have questions. Thank you.
Thank you, everyone.
Yeah.